Alright, so let's say we have a variable. So int o is equal to whatever. Say int o is equal to 5. Now we could print. Let's say I comma int. I mean comma o. So now let's run our project. So now print the integer one, which is 5. But we could create a pointer variable. So let's write this thing here. So let's call it PTR. I'm gonna set it equal to this thing. So that thing basically allows us to, point to O. So now basically allows us to point to O. And it basically allows us to see like where in the memory O even is. So let's print PTR. So you're gonna have to write P over here. So it's gonna print out its location in memory. Now I'm gonna write this. And print this weird number. So if I have another integer, P, let's make it to be 8. So now let's have another integer, PTR2. It's gonna be the basic for P. So here, if I write PTR2, and I run this, it's gonna show PTR2's adjusting the memory, which I mean is it's different. So now let's say I change PTR. If I change the value, the memory just won't change. So let's say I change P to long, and memory just going to change. Memory just going to change a little bit because, well, duh, it's a different data type. So we can see this in action. Just print an I. Next I will be size of P. So yeah, it's supposed to be LU, long unsigned or whatever. So now it's gonna say 8. So P is 8. So O, an integer, has to be 4. So that's why they have to be different locations in memory, because it's a different sizes. Right, so the next thing is to, you know, so let's say we just have a pointer, and then if I repeat it, or oh yeah, I didn't mention this earlier, but a pointer is its definition is a variable storing the memory address of something. So anyways, so back to my cool example. So you can see that if we use this asterisk thing, it's gonna show the value 0x9. Its O is 9. So yeah, also pointers can be formatted 2 ways, either this way or this way. But I mean, yeah, it can be any way you want. So yeah. Anyways, the next thing is how we can use pointers with arrays. So let's say you have uh pointer. Let's say O is an array. So let's just say, oh yeah, before we get to the array example, we can do pointer arithmetic. So let's say int pt o is equal to ptr plus 1. So now let's print pt o, and gonna show that thing. Now if we print PTR, it's gonna show, well, that, oh yeah, I have to remove this from PTR, GTO. It's not just this P and now go back PTO. And now we want to see both of them side by side. As you can see, they're the same things. Yeah, they're almost the same things, at least. Just a couple numbers are changed. Numbers here are changed. But, I mean, yeah, they're like almost the same. So let's say PTR plus 10 or something. Then we're gonna get a bigger one. Or yeah, it seems to be bigger, whatever. So yeah, anyways, back to the array thing. Let's say it's ARR is an array. So it's ARR is an array. It's gonna consist of 5, 9, 2, 4, and 10. Right, so I'm gonna run through all the elements. There's a for loop. For and r is equal to 0. R is less than 2, 3, 4, 5. Well, what's it like 5? R plus plus. So I'm gonna put these brackets over here. Okay, so now I'm gonna print f. So I'm gonna print out where. So now let's run it. Yeah, I have that semicolon here. So now let's run it. It's gonna print all the elements. We'll just add a space bar. So if I print the pointers, the memory just of all the elements, then it's gonna say all these. As you can see, they're basically the same thing. But you might notice something. You know that the size of an int is 4. So you know the size of an int is 4. Oh, this. The other bit is 80. And here, it goes 84. 80 plus 4. Then 88. Then 92. Then 96. Keeps adding 4 every time for each of the elements. Let's say it's a long. Longs have 8. So now that we run it, it's gonna say basically the same thing. But it's gonna keep adding 8 instead of adding whatever. So you'll see there's an 8 difference. Anyways, back to integers. So if you go write a pointer, so I'm gonna write int ptr is equal to memory address of array 0, 0 elements. So I'm gonna print the pointer right here. So I'm gonna print ptr. It's gonna say this. So now let's just change this to asterisk ptr. It's gonna tell us what the value is 5. But let's say let's call this underscore ptr now. So now let's say so real ptr is equal to underscore ptr plus 1. What's that gonna do? Well, obviously it's gonna do nothing because okay, actually never mind. It changes to the next value, which is 9. So if we add 2, for example, it's going to say 2 because 2 is the third element. If we add 4, it's going to say A. A is 10 hexadecimal. The hexadecimal we're doing here. So if we say plus 5 though, then well, it's going to say 0 because well, there's sort of nothing there. But then if we go after 5, well yeah, also side notes, every array ends with this 0. You can't actually see it, but after this 10 it's actually a 0. It's always there. Anyways, if you go after 5, you're going to start seeing these weird numbers, which, I mean, yeah, we're going to talk about them in another tutorial. Speaking of the tutorial, that's the end of today's tutorial. If you enjoyed, like and subscribe. So, bye.